let's keep moving.
Thank you, Sean, for that introduction and explaining my accent, because that's usually the first thing I try to do. Let me share my screen. Okay, as I can't see what you see, does that look right, Sean?
Yep.
Okay, great stuff. Okay, so I'm going to roll into it because they only gave me 20 minutes to give background about what we do and do not know about grape smoke exposure, and there's a very long list. So I like to start with, because everybody's talking about smoke taint, and I am an educator, so I like to start with, okay, what's a wine taint? Right? And for wine taint is defined as something that comes from outside. It overpowers a wine. It makes a wine one-dimensional, thus decreasing the quality. Now, in the case of smoke taint, we've seen there's a long list of attributes. I have here smoky, burnt, campfire, medicinal, earthy, but that's definitely not an exhaustive list. You saw barbecue, bacon, spicy, tar-like. There's a lot of other things. Band-aid, chemical, all those things could be smoke impact related. For me, what's very distinctive about smoke taint is that lingering retronasal ashtray character, because almost all those other descriptives can be caused by something else as well. But that ashtray character, that's extremely unique to smoke exposure. Now, when you have a wildfire, you have a lot of vegetation burning, and 15 to 25% of wood, and that gives the structure to it, is lignin. Now, if you look on the structure on the left, you can see what lignin looks like. Now, when it burns, you get thermal degradation, and it makes sense that you will have excessive amounts of compounds, a ring structure with an OH group. That's a phenol. These are volatile phenols. That example is guaiacol. We all know now about guaiacol. The massive amounts of them get released in the air. Then they can distribute depending on air currents, temperature differences. There's a lot of atmospheric differences that influence how far and wide volatile phenols spread and how quickly they move. They can also use debris in the air, like ash, as carriers to distribute further. And this is why we always say smoke does not equal smoke taint. Only when smoke is really fresh is there a close relationship between the amount of volatile phenols in the air and the amount of debris or particulate matter that you see. Volatile phenols break down much, much quicker, and ash is very stable. It breaks down within hours. So this is why the older smoke gets, the less there's a relationship between the particulate matter that you see and the risk of smoke taint development. However, the absorbance of volatile phenols onto debris changes its degradation speed, and that is something we need to still study and get the answers to. Now, when you have toasting or charring of barrels in the case of bourbon, you're basically doing the same thing, just in a much more controlled manner. So when you're toasting a barrel, you're releasing volatile phenols, but in a small amount, it is actually giving an extra dimension to your wine, increasing the complexity and improving the quality. So wildfire smoke is really a matter of too much of a good thing isn't a good thing anymore. Remember, both free and bound volatile phenols are present in grapes naturally. Different varieties have different amounts, and we don't know why. And there's also a seasonal impact and a regional impact. So this is a really, really complex question. However, I don't know of any grapes that have never been exposed to smoke, making a wine, that wine going into a toaster barrel and developing smoke impact. Smoke impact has always been related to some smoke exposure in the environment. So if you have smoke in your vineyard, fresh smoke, and there's volatile phenols in the air, they actually absorb into the leaves and into the berries. If they're present in the vineyard, they're susceptible, even if they're rock hard green berries. It absorbs through the berry very quickly. It's within the skin cells, and it gets glycosylated also very quickly, within hours. You can have various sugars attached, 1, 2, or 3 sugars. So you can think you have now a range of volatile phenols being released depending on the vegetation burning. Then there's a range of different sugars that can be attached in different combinations. So you can think this is a very, very complex issue. So this is the range of volatile phenols most researchers would analyze. Many of us analyze even more, but these 7 have been shown by the Australians to correlate pretty well with smoke taint characters in the wines. And then they quickly realized, oh, the bound also contribute to smoke taint. So now they have this list of 6 bound compounds, but there are many, many more there. And there's still a question of, are these really the only compounds we should analyze, or should we analyze more to improve our predictive power? So this is an unfortunate situation you can have. Free to bound, like the poll showed, there is no set ratio of free to bound. It varies all the time. The Australians have many instances where they have no free and a lot of bound. Is it because they usually get their smoke exposure much earlier than we do? Is there a genotypic impact on this? We don't know. And this is something we need to study further. I'm not going to talk about techniques because Eric is going to cover that. Then what happens during winemaking? These compounds are in the skins. So very quickly during winemaking, they extract and they into your medium. So that there's one study in Merlot at a 25 degrees Celsius fermentation temperature where 7 days was like 100% extraction. And you can see within 5 days, you had more of 80% of both the free and bound that was there. During the winemaking process until malolactic fermentation, we've seen 25 to 30% releasing. Australians have seen up to 50% of the bound releasing. This is because matrix have an impact, as well as the concentration there. There's always a concentration-driven effect with extraction. Their grapes have way more bound than our grapes when they did this test. So this is very important. The other thing is both free and bound contribute to what we call smoke taint. They've shown that people have bacterial enzymes in their saliva that can hydrolyze the bound compounds. And we think that makes this really significant contribution to the ashtray retronasal character that you get. It's those bound compounds getting hydrolyzed with your saliva during the tasting. And this is also why it has such a heavy carryover effect. And it also has a little bit of a buildup effect. Basically, what I found is they extract very quickly. They're also glycosylated like pigments. So whatever you do to get pigments out, you're probably also getting all your volatile phenyls out, bound and free. There's a huge problem because we actually know the threshold levels of all these compounds, but it's not very useful, like we found. We see that all these compounds can be a problem in wines and actually cause smoke impact at 10 times lower levels than the threshold levels on their own in a base red wine. It's because they have synergistic impacts with each other. Another thing is the matrix have a huge impact. We know a little bit of sugar, 3 grams per liter, can inhibit the contribution from the bound because it inhibits the enzyme in your saliva. 14% of alcohol or more can do the same thing. A lot of phenolics can help hide that volatile or that retronasal ashtray character. Volatiles, a lot of fruit, can hide the smoke on the nose. Green character can uplift the smoke on your nose. So basically, to have a threshold level that is useful, you will need thresholds of different combinations of all these compounds contributing to smoke taint in different varieties, in different wine styles of that variety, so that you can have a better idea of what's threshold. And threshold in this case for me should be consumer rejection level of a wine. When does the consumer think this is an impacted wine that's decreased in quality and something they don't want to buy? Then huge human variability. The Australians have found, as they've made a big drive to, in all their wine regions, train objective wine panels to evaluate bucket fermentations if they're impacted by wildfires, and they found that 20 to 25% of people are not sensitive to smoke taint. They think they don't have that enzyme in their saliva, or very insensitive to smoke taint. So this is also very important to train your panelists and check with high impacted standards and no impacted standards, whether these, with standard I mean a typical wine, to make sure that they first can see smoke taint, and secondly, don't see smoke everywhere. You get that too. People so looking for smoke that they find it in anything, even your control wines, that never seen any smoke. So I did studies in 2017. That's quite complementary what LAFFORT did here. I basically said, okay, this is the first time we had a lot of wildfires since I've been in California. And I did this only in Cabernet Sauvignon. The Australians have been making all these recommendations, but it's research they've done over several years in different varieties, using products that we don't typically use in the US. So I did 4 different years. And actually, I found that BDX and D80 had really pretty good impact on hiding the smoke on the nose. However, the Australians didn't find very good impact with BDX, for example. And that just shows you the impact of the matrix, because something works in one wine doesn't mean it's going to work in another wine. And this is very important to note. Then they said, okay, add oak, like oak chips or any other oak products that have no toasty or nutty or any kind of those nutty aromas that remind you of smokiness, but only uplifts fruit and built body. So this is why I used Nobile Fresh and used Nobile Base. And then they also suggested use a Lagitanin. Now in this set, the Nobile Fresh actually worked really well in hiding the smoke on the nose. The big disadvantage, it came back. After some period of time, it unfortunately came back, and it really can't hide that ashtray character very well. This was the first year we looked at this. So we also looked at just, adding in the maceration enzyme, getting all the color out, adding a tannin to stabilize the color, press after 3 days, and ferment without the skins. But unfortunately, that maceration enzyme and everything you do to get the color out also got all the volatile phenols out. So that didn't work very well. And then I looked at different fermentation temperatures, because the Australians say, do a cool fermentation. But I did a constant 7-day skin contact, no matter what. Even for the 10 days cold soak, it was 7 days. Then I pressed off and finished the fermentation. And none of those helped. At 7 days, the volatile phenols and the bound were out and already extracted. So it's just something to remember. But like I said, this is for the wines matrix that I looked at. It's clear to me the wine matrix has a huge impact. So currently what we say, what mitigation do we know of? White wines, because it's in the skins and you have the option of avoiding skin contact as much as you can. If you can do hand picking, exclude monk because we know it's in the leaves. At this point, we say exclude rachis. We're not sure about rachis. Light pressing, we know that mechanical force of pressing, as soon as you do that, you start forcing more of the volatile phenols out in the skin. Then what about finding in juice? If you know it's impacted and you smell it in your juice, rather treating your juice than your wine. It's just an option, because we know the earlier you treat, the more time you have to use your winemaker tools and other tools available in the market to perhaps build it back up. We know at this stage, we only know about activated charcoal known to remove both free and bound. I think there's a lot of other products that have some potential here. And then using other things to build it back up, because at this point, anything you find with, unfortunately, do impact aroma overall and do impact body overall as well. For red wines, you can use, I think, really on low impact, fruity yeast, light toasted oak and things may make a difference. I don't know how long it will last. But as soon as you go to a higher impact, there's just not enough you can do to really fix a wine at all. Rosés sometimes is an option. For many, that's not an economically viable option. Something to remember. For a rosé with less skin contact, you will get less of the volatile phenols. But because it's a much simpler matrix, a smaller amount can still result in a problem because the threshold would be lower in that matrix. I know people have success where they had inventory that wasn't impacted and could just press off, donate skins, and do a fermentation in that way. In general, what I'm saying, if you have a red wine, it's medium to high impacted, and you have to make that wine, I say make the best one you can. As much as phenolics, as much color, as much fruit as you can, because whatever you're treating at the end is also going to impact the overall composition of your wine. The Australians are going the other route. They're saying as little as everything. But I'm just thinking it stand out more. And my discussions with winemakers, and both in Oregon and here and in Washington, a lot of us are moving let's go fuller body, so that we basically have more there that will be left after the treatment is finished. So I did look at emulation. I looked at 4 different enzymes. The Australians looked at 15 different enzymes. And variable impact, nothing that really worked well enough for any of us to make real recommendations. I looked at activated charcoal bonding and molecular imprinted polymers. Now, the latter, unfortunately, is not available in the US. It does show some real promise. Then reverse osmosis, standard differential filtration, and then spinning cone technology. I did this on 4 different wines. I had a high impact one from the Light County fires in 2018. I kept the press and free run separate. I had more medium impact from Lake County, and then I had a lower impact from my 2017 from my Oakville experimental station wine. And what I want to show you here, this is the total free about of volatile phenols. And you will see no matter what treatment you used, it decreased. But there was still plenty left. But remember, you don't have to remove everything. Naturally, you have free and bound in your grapes. Grapes that have never been exposed to smoke do not result after 10 years of aging in smoke impacted wines, never. So all you need to do is remove enough that you're in what is normal. But the problem is because we don't have good baseline data, we don't know what to aim for because we don't know what's normal for that specific grape and for that specific wine that you're making. We did do descriptive analysis. So LAFFORT in their tasting suggested rinsing with water and waiting 2 minutes, and that's perfect. That's what I always suggest as well. For our sensory evaluation, we went for 0.1% pectin solution rinse and 90 seconds, and that worked as well. But because we used the pectin solution, it works a little bit better than water. Now, what I quickly want to show you here, this is only the significant attributes. The green circle, those are my 2 controls. Now you look on the right, you'll see there is right bottom, there's ash and peatwood smoke. Now peatwood smoke was what the panelists used for the smokiness on the nose, and the ash is actually ashtray. That's the ash retronasal observation. And what you see, the control was orthogonal to that, meaning it wasn't impacted at all, which is good, no carryover. Then what I want to show you is wine 3 and 4 with a low to medium impact wine. All the techniques, even though some worked a little bit better than others depending on the wine matrix, those that were lower impacted, all the techniques worked better. The wines that were highly impacted, it works not as well because it can only remove so much before there's nothing left in the wine and the wine is totally stripped. And I treated all the wines the same because remember, this is research. I can't publish something if I treated all the wines differently because then I can't compare them with each other. But what was really clear here that is that you will need to do bench trials. And because you find something that worked perfect perhaps for one of your wines, that doesn't mean that that is going to be the solution for the rest of the wines. The matrix have a huge influence on the success of anything that you try in this focus area. So to summarize, there is really not a solution. There's things that work, help. There's things that we know will remove the free and the total or the bound. It will remove way more free than bound, always. Flash to Taint. Now, flash to Taint, I know I haven't studied, but several winemakers that I know have, and I've tasted their wines and looked at their data. Flash doesn't actually remove a lot of volatile phenols. It removes a little bit of the free if you do not add the flash water back. However, it does mask. Because you have so much phenolics extracted, so much fruity character extracted, it hides it. Now, is there a limit to where it's so impacted it can't hide it anymore? I don't know. What's the tipping point of when it's successful and when it will last for the lifetime of the wine? That is what I'm not sure about. So for 2020, I did a lot of different trials based on questions I received that I didn't know the answers to. One is the whole question of ash. I'm less concerned about ash in the vineyard than I'm concerned about fresh ash on grapes when they get to the winery to be processed. You know, if there's fresh ash smelling like smoke during their winemaking process, does it release those volatile phenols from the ash into the wine? So we did some tests on that. The question of racus, does racus have an influence? So I did whole plus suppression for Tarantas, and I did actually whole plus fermentations for Cabernet Sauvignon. I looked at activated charcoal finding in juice versus in the wines for Tarantas and Sauvignon Blanc. Cabernet Sauvignon, I once again looked at this matrix effect. Rosé versus a full-bodied red wine, free run versus different press factions. And then I also made quite a large quantity of what I would call 9 out of 9 smoke taint rating reference wine. from a vineyard that was surrounded by fire. So the idea is when one day we can do workshops in person again, I would love to set up some training sessions about how to evaluate for smoke taint and using these reference wines. So Taicam, unfortunately, the big thing is smoke does not equal smoke taint. Remember, there's no carryover from one year to the next. So you start fresh every year, which is a good thing. Although data analysis is really, really important, it gives you a very small piece of the puzzle, okay? You get like 1 or 2 pieces. Doing bucket fermentations and doing sensory analysis just give you a little bit more information to make a decision, right? To predict everything you get, every single additional piece of information you get, give you more information to try and make a better informed decision of what would your wine look like if you process these grapes? What are your options if you make these wines? And having a bucket fermentation wine makes it much easier than tasting a berry and needing to see into the future. There's no mitigation in the vineyard. I know there's some barrier sprays being looked at. Some of them show some potential, but not consistently. So we have more work there. I've told about limited mitigation in the winery. Amelioration options, they work, but they lack specificity. We've tried things that are available. I think now is the time where we need to really start developing tools that's specific to this problem, developing enzymes for this problem, developing resins for this problem. Thank you very much. I need to quickly mention just funding that I had up to this point and the people working on this with me. And also, obviously, loads of in-kind donations that I'm not even putting here, right? Products, grapes, the list goes on. And a couple of pictures from Harvest 2020. Thank you very much, and I hope I didn't go over my 20 minutes.
That was fabulous. Thank you, Anita. Your timing was perfect. And if you did go over by a couple of minutes, it was all fantastic knowledge. So that's quite okay.
Thank you.
Our next speaker is Dr. Eric Hervé.